Okay. Right. Okay. So yes. Okay. So in connecting rod assembly, we have done almost all the parts. Now there are leftover is another two to three parts. One is a major one, the other one are very small, and then we'll see the assembly. Okay, so next is going to be part number 7 that we have left out. That is the cover for the connecting rod. Okay, now yes, here we have the um, yes, yes, here we have the cover for the connecting rod. Now this, yeah, so they're given the front view and the side view for this. Okay, right? Now top view, let us see if they have given. No, they have not given the top view. Okay, right. So yes, so what is the total width of it? It is about 20 mm. Okay, and from the other view, the thickness is for 33, and it's a semicircular one. And yes, so we have a separate conical section with a countersink hole over here at a particular angle. We'll see how to do this, right? And yes, next will be okay. So the next thing is that yes, if you look at these drawings on both these ends, you have a dashed line indicating a hole for which the dimensions of this is two holes of 10.5 mm diameter. Okay, and there's another thing which is the spot face, right? That is an extra projection over here, okay, which is for a diameter of 18 mm. Yeah, right? And yes. Now coming to the major thing is that what is the radius of this semicircular arc and what is this? Now if you look at this carefully, this edges of this is going to be here, but there's a gap of 1.5 mm from the center of the uh, radius that we are going to draw from the center of the arc. Okay, and what is it? The radiuses are one is the diameter is 48 diameter, that means radius is 24 over here for the inner one, and for this particular circle the radius is 29. Okay, and the next thing is that if you see here carefully, they're given a sectioning line with the alphabet B and B. That means they have shown a section over here how its cross-sectional view will look like, for which it is here. See, section BB. Okay, so it's going to be kind of curved on one side and flat on the other side. So the minimum thickness is 5 and the highest thickness is 6.5. So it's a curved surface, not exactly a flat surface. Yes. Okay. Then coming to this, here we have at the base of this cone that is there, at the base its diameter is, okay, just a second. Okay, yeah, at the base. Now just look at the dimensioning line carefully. I'll just zoom in. Yeah, look at this dimensioning. This dimensioning line is going here. That means at this particular place the diameter is 12. Okay, and then at the top at this particular place the diameter is 10, and this is inclined at an angle of 30 degrees. First thing. Okay. Second thing, where should it be placed? They are given another data. Where should it be placed? Right. So if you look at this carefully, from the center, if you draw a horizontal line from the center of this arc, if you draw a horizontal line that is exactly at mid point or half of this part, from there this height should be at 13.5 mm, where it should be the center of the countersink hole that we are going to do. Right. If you look at this carefully, yeah. So this 13.5 mm, where is this dimension line going to? It is going to the axis of the countersink hole. Okay, right? So these are the details that is being given. And yes, the then this distance is where we have this countersink hole should be at a distance of 40 mm from where? Okay, from this base edge over here. Okay, not from the center of the arc that we are drawing. Okay, right. So these are the details that has been given. Then yes, okay, the overall distance from the center of the two holes that is placed on either side is for 60 mm. Okay, right. So these are the details that has been given. So we'll construct it one by one. Yeah. So let us see how to do this part. So take the side view plane. Okay. So overall distance between the two holes was 60. So they are taking offset from the horizontal line by 30 mm on either side. Okay, for a diameter of 20. It's actually better that at now itself we uh, take the dimensions and maintain it at 60, so that when we make any changes, these two circles do not get displaced. Right? Now from here, they'll take 1.5 mm offset. Okay. Yes. Now draw the two arcs that is required. One is for a diameter of 48, the other one for a radius of 29. trim the unwanted lines and arcs. Yes, now this will be for a distance of 33. Okay. So you can extend it, you can use symmetric extend. So here we actually need, it's of sharp perpendicular edges. We need a inclined edge with a tangential surface. I mean arc. Okay, so that is why we are constructing this, and the area within these blue lines will be cut off. So using the cut option, cut it throughout. Go to whole option. Sorry, we can even draw an arc, and we can use cutout once again for this. So the next hole for the 18 mm diameters. So we'll offset this line for a height of 13.5 mm and another offset from the vertical line for 40 mm distance, which they've given. Now we are trying to, now we'll be doing the that inclined conical shape. From here, we'll draw an axis line, an angle of minus 30 degrees. Okay. Now, keeping this inclined line as the one, we'll create uh, the cone. So on the top side, we need diameter 10. Bottom of the cone, we need diameter 12. So that's why they offset two lines. From here till this meeting point, we'll join the line to these two corners and go for revolved. First trim the unwanted edge lines and then go for revolved cutout. Sorry, revolved protrusion. It should be for complete 360 degrees. Like this. Now for this we have to create the countersink hole. Yes. So now you can save it with giving all the details of the part. What is the name of the part, material, the project number, document number, and so on. Okay. So the next thing is that after the cover we have is the nut Okay, washer we have already seen in the last class. Nut and split pin is there. So nut, if you see here, it's a hexagon M10 nut. Okay, with on all the six edges of the hexagon nut, there's a cutout for 2.8 mm width. Okay, and this cutout is for a depth of 4 mm. So overall height of the nut is 12. In that, for 8 mm there is no cutout. For another 4 mm the split is there, right? Okay. So we'll see. So we can create a hexagon first. So there are different ways to create the hexagon. It's been done in a different way over here. So for a protruded for a height of 12 mm, create a hole, threaded hole. Okay, M10. Offset the line. We have to give the rounded surfaces onto the nut. Go for revolved cutout. We'll offset this vertical line by 1.4 on either side. Total width of the slit is for 2.8 mm. extend this on both the sides, cut out. Now this same sketch has to be repeated on two more sides, so that all the six surfaces, I mean all the six sides of the nut is got this cut out. So we'll have to repeat this same procedure again twice. Now go for cutout once again. Save this part. Right. Okay. So the next thing that we have here is the last part, that is the split pin. Okay. So here we have the split pin. So here we have total width, total height of this, including both the uh, circular one, circular tiny rod that is placed very close together with a U bend, is 2.5 mm diameter. Okay, and the width of this shorter one is 25 mm, right? Okay, so we'll see how to create, to do this part. Okay. second. Okay, 1 second, 1 second, just a second. Okay, so we'll that is there. So we'll see the assembly because almost everything has been done. Right, so we'll go to the assembly mode, okay, and we'll start assembling the parts. So we'll first get the connecting rod in, and then comes the cover. But before this, we can even keep the distance piece. Then get the bearing brushes. The curved surface on top of the bearing brush should match with the inner surface of the cover as well as the connecting rod. This particular yellow edge should match with this. the top view after assembling the bearing brass is shown. Go back. There's a gap of 3 mm in between this because 1.5 mm, okay, from the center of the arcs that has been drawn for the cover and the connecting rod. So we offset the plane to keep it in center. We mirror this bearing brass instead of assembling it once again. Now comes the distance piece. It should be between the connecting rod and the cover. So align it with the hole that is already there, then with the edges. So we can even mirror this once again with the horizontal plane. And go for the stud. So this should be only for a particular distance inside. So yes, so we are actually measuring the distance for the hole that has been made on the stud and the hole that has been made onto the connecting rod. So it's around 15 mm. This is not the only way to assemble it. We can also assemble it uh, by aligning the axis of the two holes, and these two tiny holes can be aligned next in the next step, the perpendicular holes. So yes, you can see here it has been exactly fitted over here. Next comes the washer. Bottom surface of the washer should fit inside the cover. Let's assemble the nut. Then comes the pin. That should be holding the connecting rod and the stud. And another feature on both the sides, even the nut and the washer also. If you can select see pin, nut, washer, all of them, this assembled on one side can be mirrored by using the horizontal plane as the mirroring surface. Now we'll go for the bush that has to be inserted onto the small end of the connecting rod. There's a tiny hole that has been made for the oil to flow that has to be matched with the hole that has been made on the small end bearing side of the connecting rod. So we'll have to align it. So man, align this. Yes, assembly is over. Save this assembly. Now go to solid edge file, that is in 2D mode. Now go for top, front, and isometric view. Go for sectioning. Click on part list and click on the front view of the assembled drawing. You'll get the bill of materials. See, sometimes if you don't enter the parts, title, and so on, it will be blank over here, which will be very difficult to edit it later on. Okay. So as and when the part has been created, give the details of that part immediately. So this is the connecting rod assembly. So yes, answer attendance. Madhu P absent, not there. Motion also not there. Yes, Naman Shivananda.
Present, sir.
Srikanth.
Yes, sir.
Parthasarthi. Rahul
Present, sir.
Rathod. Rahul Rathod. Rahul. Rajat M. Patel.
Present, sir.
Reni Sibbi. There. Rohan Unikrishnan is also not there. Shreyas. Not there. Samath,
Present, sir.
Sayan
Someone present.
Govardhan,
Present, sir.
okay. Sayatan Banerjee,
Sir, he's texted in the chat box.
okay, right. Shashank KS,
Yes, sir. Present, sir. Sir,
Shashank
Rahul
MB,
has some. Sir, Rahul has some technical problem. It means he's working. He's texting message, sir.
okay. Shashank MB, it's not there. Shiv Kumar Patel, it's also not there. Sri Harsha Prasad,
Sir, present, sir.
okay. Yes, then Shubhankar Singh, absent. He is also not there. Right. Okay. Uh, so practice these drawings, assembly drawings. I have pasted the link in the Google Classroom for this assembly drawing so that you can access the video. Yeah. For the connecting rod, right? Okay. So practice this drawing. Though it may seem a little bit difficult, don't leave it. Okay. Practice it. You will get it. It's not that difficult. Okay. Right.